Good morning, students. I think for J1 and J2 I completed quantum numbers, and again I am going to recall that quantum numbers because based on that we are going to discuss about classification of quantum numbers. J1 as I completed this structure of atom. Once again you can view this because I have not completed for J2. Okay. Now we are going to discuss about quantum numbers. Quantum numbers and in that we are going to discuss about classifications of quantum number, that is principal quantum number, and azimuthal quantum number. See my dear students, azimuthal quantum number and magnetic quantum number, spin quantum numbers. And after the quantum numbers, today we are going to discuss these topics, that is ionization energy, and after that we are going to discuss about de Broglie relationship. Okay. We'll discuss this relationship by taking the lambda is equals to c by frequency. Okay, using this formula we are going to discuss, and also we are going to discuss about de Broglie wave or matters waves and significance of de Broglie waves, and also we are going to study about applications of de Broglie equation. We will get the equations. Based on that equations we are going to discuss applications of de Broglie's wave equations to the Bohr's theory, and also we are going to discuss this Planck's quantum theory, and also Planck's constant, and we are going to discuss today class, that is last topic, that is Heisenberg. See, I see that plenty of students are making the spelling mistakes. De Broglie's and Heisenberg. Please make the corrections on your notes. Heisenberg uncertainty principle. Heisenberg uncertainty principles, and last of this topic today class, that is relationship between a pair of conjugative property. Okay, today we will discuss all these properties. Okay, see, these are very important, that is these four quantum numbers are very important for your exam purpose, and also de Broglie's and Planck's constant, because today class what we discussed in this topic, surely the very important topics to your classes. For that you want to go through it. Already you have the notes what I given. Now we are going to recall this once again. Okay, if you have any doubt on the topic, you can message me. Good morning, students. Today class we are going to study about quantum number. What is this quantum number? Means quantum numbers. The quantum number is nothing but a set of number used to describe the position of electron and energy of electrons. You see, we know that this is the atom, it's a nucleus, the electrons revolving. Means a quantum number is nothing but a set of numbers. Means electrons, numbers we are talking that electrons means in orbital which positions are there, and energy of electrons means what we are going to study. Set of numbers used to describe the position and energy of the electron in an atom is called quantum number. Okay, there are four types of quantum numbers. Mainly there are four types. Number one, first is principal quantum number, is denoted as small n. Second one is azimuthal quantum number, it is denoted as small l. Next is magnetic quantum number, it is denoted as m. L also. Some books will tell M, some another NCERT books tell ML. Another last quantum number, that is spin quantum number, it is denoted as MS. These are four quantum numbers. First, I already told what is quantum number, a set of numbers used to describe the position of the energy of the electron in an atom is called quantum number. In that, first we are going to study about principal quantum number. First we are going to study about principal quantum number, denoted as small n. Okay, what it will explains the means, you see it first of all, principal quantum number will explain the in atom means energy of the electrons. First, the principal quantum number, it explains the energy of electrons in the orbitals. Okay, energy, and also it explains first point what I told, energy associated with electrons. Energy associated with the electrons. Next, the second point, you see average distance of means the distance of the orbit nucleus to electrons. Means it also explains the average distance of electron from nucleus. Second point is over. It explains only the main shell present in the electrons, means main shell in this orbital, means K shell, L shell, M, another one is N. Okay, it explains the main shells. it explains the main shell in which electrons is present, that is K, L, M, N, so on. Means you see in principal quantum number, very important, that is N, small n will start from 1 to so on, but never from 0. Please, you want to remember, in principal quantum number n will starts from 1, never from 0. When we talk about energy of orbitals, we given the one formula. It's very important in the principal formula. We have already solved some problems. Previous video I solved the problems. That is energy of nth orbitals. Energy of nth orbital, En is equals to minus k square 2 pi square m to the power of 4 divided by n square h square. This we can write that En is equals to minus 2.18 into 10 to the power of minus 18 by n square units joules. This is the principal quantum number. In principal quantum number, we study the energy aspect with the electrons, means energy of the electrons will be explained, and average distance from electrons from nucleus, and it explains the main shell of the electrons present in K, L, M, N. It explains like that. That main shells are, it is K, L, M, N, and N means principal quantum number starts from 1, never from the 0. Energy of nth orbital is nothing but, they give the formula, En is equals to minus k square 2 pi square m e to the power of 4 by n square by s square. Okay. Next we are going to study about azimuthal quantum number. Azimuthal quantum number. Okay, azimuthal quantum number. You see, in this the previous principle I told that it explains the main shell, but in this azimuthal quantum number, it gives the information about subshells. Means you see, again I want to write this atom. K, L, M, N. In K, S, P, D, F orbital subshells. Okay, means it explains or gives information about presence of electron in subshells, that is S, P, D, F, and also the azimuthal gives the shape of the orbitals, that is dumbbell shape, spherical shape, like this we'll talk. Now the azimuthal quantum number is denoted as small l. Already I told that small l will start from 0 to n minus 1. For example, if you take a principal quantum number n and l, if n is equals to 1, l formula n minus 1. 1 means 0. If n is equals to 2, it will become 1. N is equals to 3. L value is nothing but 2. This is the azimuthal quantum number. Next we are going to study about magnetical quantum number. Magnetical quantum number It is denoted as ml. Means in magnetical, what it tells, it will be orientations. Means the orbitals, means atomic orbitals moves in orientation d. It moves in orientation d. It moves in orientation d. You see, for example, if you take magnetic quantum number moves orientation of atomic orbitals. It has a formula ml is equals to 2l plus 1, 2l plus 1. If we talk, now we are going to do substitute if n, l, ml, okay. If n is equals to 1, if n is equals to 1, we know the formula L is equals to n minus 1, correct no? Then it becomes 1 minus 1 becomes 0, correct no? If we substitute 0 in ml, we have the formula 2l plus 1, correct no? If we substitute 2 into L is nothing but 0, 0 plus 1, it becomes 1. 1 means we know this 1 electrons is nothing but S, correct no? Electrons. If we talk n is equals to 2, n is equals to 2, then what will happen? 2 minus 1 became 1, correct no? But already I told you L starts from 0, L starts from 0, L starts from 0. For that we will take n, sorry, L is equals to 1. For that we take 0, 1. You understand here? Okay. Then we are going to write first what is the L value? L value is nothing but 1. 2 into 1 plus 1, correct no? 2 plus 1, 3. 3 means it starts, you see, this mathematical quantum number will have 0, right hand side must be minus, left hand side plus. Okay, this is main important while doing. You see, 3 numbers must become, for that what we write? 0, correct no? We start from 0 only, 0 minus 1 plus 1. It become 3, correct no? See, it become 3. 3 means it is P. Then we can write it is a Px, Py, Pz, correct no? Next, while we are going to see another one. If n is equals to 3, n is equals to 3, what happened? If n is equals to 3, then L is equals to 3 minus 1, correct no? Is equals to 2, then it starts from 0, 0, 1, 2, correct no? We got ml formula is n minus 1, it is 2l plus 1, correct no? 2 into 2 plus 1, it becomes 5. 5 means 0, minus 1, minus 2, plus 1, plus 2. See, it is 5. 5 numbers are there, become 5. It represents, it is a d orbitals. D orbitals means I will see 5. dxy, dyz, dzx, dx square, y square, dz square. Next, last quantum number, that is spin quantum number. Spin quantum number. You see, spin quantum number is denoted as ms. Spin quantum number is nothing but if you take up the atom, and to take a clock, for example, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You see, if it moves in clockwise direction, it is clockwise direction, clockwise, then it is plus off. If it moves in anti-clockwise, it is minus off. Anti-clockwise. Then ms will represent spinning of the atoms. Ms will represent that spinning of the atom, maybe plus or minus of. Okay. Next, I will write this in one tableau column. One tableau column, very important. That is tableau column. That is will represent that possible. Okay. First, we will write I'm going to write. See. First, energy n, possible value of L, then another one is designation of subshell, and possible value of Ml. Okay. First we take energy, that is K. If you take K, n is equals to 1. N is equals to 1. What is the L value? 1 minus 1, correct? No? It is n minus 1 formula. 1 minus 1. Then what happens? It will become 0. If 0 means yes, n is nothing but 1. Correct? No? N is nothing but 1. S is nothing but 0. Okay, do you understand here? Next is the possible value of Ml. Possible value of Ml. Ml is nothing but formula 2L plus 1. Correct? No? If L is equals to 0, then what happens? 2 into 0 plus 1. Correct? No? 0. Okay. Next we are going to talk about energy. Another one is, it is L. N is equals to 2. Correct? No? N is equals to 2. 2 minus 1 is equals to 1. Correct? No? While we already told that it must start from 0 to n minus 1. Correct? No? Then 0, 1. 0, 1. 0 indicates that it is S. Correct? No? N is nothing but 2. 1 indicates that P. 1 indicates P, then 2P. Do you understand here? Very important. 2P. Now while going to ML, what will write? L is equals to first 0, no? 2 into 0 plus 1 is equals to 0. One thing. Sorry, it is 1. 1, sorry. 0, 1, 0 plus 1, no? 1. And 1. 2 into 1 plus 1 is equals to 3. We can represent 0, minus 1, plus 1. Correct, no? Next, we are going to talk about M. M means it become 3 minus 1 is equals to 2. It must be start from 0, 1, 0, 1, 2. C, already explained, it is 3S, 3P, 3D. You understand why I am writing this? How can I write this? 0, 1, 2. 0, 1, 2. L value is nothing but 0, then it is S orbital. L value is nothing but 1, it is P orbital. Okay. Now I am going to write the possibility ML means how much it is there. You see, we got a 2. L is equals to 2, no? 2 means, sorry, I will write a line. You will be maybe confused. Okay. You see, 2 into 2 plus 1 is equals to 5. We can write 0, minus 1, minus 2, plus 1, plus 2. We can represent. Next, last is nothing but n is equals to 4. 4 means 1, right? 4 minus 1 is equals to 3. Must be start from 0, 0, 1, 2, 3. Correct? No. It represents 4s, 4p, 4d, 4f. 0 represents L is equals to 0, then it is S. L is equals to 1, it will be P. L is equals to 2, D. L is equals to 3, F. Okay. We know L is equals to 3, no? 2 into 3 plus 1, it becomes 7. 0, minus 1, minus 2, minus 3, plus 1, plus 2, plus 3. Okay. You understanding here? Okay. Now I will write what is this expense. You see L if L is equals to, okay, then orbitals. Which orbitals? I will tell that. If L is equals to 0, then it is S. 1, P, 2, D, 3, F. This is very important. You see, you understand. If you not understanding, sir, you can comment me. If I want to explain, 1 second, I will surely explain this. Okay. Next, we are going to solve the problems. We are going to talk about problems. Problems based on quantum numbers. Okay. First, energy. It's not a problem. It's very important formula. Energy of the electron in hydrogen atom is given. Energy of electron in hydrogen atom is given by the expression that is En is equals to minus 1.312 into 10 to the power of 6 joules per mole divided by n square. Okay. Now we are going to solve the problem. You see this problem. First problem we are going to study. Calculate the amount of energy required to promote. Calculate the amount of energy required to promote electrons from first energy level to third energy level. What they telling? Calculating the amount of, means we want to calculate the amount of energy required to promote electrons from first energy level to third energy. Means how much energy must be required from first energy to third energy. Okay, first we want to divide. First we will write that first energy level. We know formula. En is equals to minus 1.312 into 10 to the power of 6. First energy, for that we will take 1 square joule per whole unit. The En is equals to minus 1.312 into 10 to the power of 6 joule per mole. Next we want to find out, they ask me third, correct? No, third energy level, that is En is equals to minus 1.312 into 10 to the power of 6 divided by 3 square, because third energy 3 square joule per mole. If we calculate, we will get minus 1.408 into 10 to the power of 5 joules per mole. We got we can write this is E1, you can understand easily, E1, this is E3. Now we are going to calculate change, how much the change between these two. Okay, for that the energy change is equals to E3 minus E1, will get minus 1.408 into 10 to the power of 5 minus 1.312 into 10 to the power of 6, correct? No, minus plus it becomes, okay, the overall plus 11.66 into 10 to the power of 5 joules per mole. The energy required to promote the electrons from first orbital, means you see the first orbital, means first orbital to third orbital, you see, first 1 2 3, first orbital to third orbital, this much of energy must be required to promote the electrons from first to third. It is plus 11.66 into the power of 5 joules per mole. Okay, next we are going to talk another problem. That is what will be the ionization energy of the hydrogen? What will be the ionization energy of the hydrogen? Okay. What will be the ionization energy of hydrogen? First of all, what is ionization energy? What will be the ionization energy of the hydrogen? What is the ionization energy? Ionization energy is nothing but the amount of, okay, I will write like this, ionization energy in short form, ionization energy, amount of energy required to remove the electrons from outermost shell. Means ionization energy, it is outermost shell, means we don't know they are not telling that how much the outermost energy. Okay, if you take the energy, first of all, energy is nothing but first ground state will be E1. It is outermost. They are telling what will be the ionization energy of hydrogen. Ionization energy means removing the electrons from outermost. Outermost maybe it is infinity. It is infinity. The ionization energy are infinity minus E1, or else, why we want to confuse, we can make a delta E only. Delta E. Infinity is 0 minus 1.312 into 10 to the power of 6 joule per mole divided by n square. Correct? No? N square is nothing but 1. 1 will get delta E is equals to 1.312 into 10 to the power of 6 joule per mole. Okay. Next we are going to study about de Broglie relationship. You see, before talking about de Broglie relationship, the Einstein given that the particles in wave nature and wave nature and particle nature. When come to de Broglie, will tell that the electrons will move in the straight line only not. It can straight line only not. It can move on the wave also. It may move on the wave also. Okay, it was like that. The electrons will not move straight only. It can move in wave all. You will tell that. You see, derivation for the de Broglie relationship. We know that E is equals to h nu. Nu is nothing but frequency. H is nothing Planck's constant. Energy of the photon. We have the formula E is equals to mc square. The equation 1 and 2, if we substitute, mc square is equals to h nu, mc square is equals to h c by lambda. Why we take the c by lambda? Mu is nothing but c by lambda. If we substitute in this, we will get lambda is equals to h by h into c divided by mc square.
C square and C will be cancelled. We get lambda is equals to H by mc. M is nothing but the mass of the protons, but instead of mass of the protons, de Broglie will take that not a mass of the proton. You will take that mass of the particles instead of mass of the photons. Similarly, you take that C is the velocity of light. Instead of velocity of the photon, you will take that velocity of particles moving in a. You take that velocity. No, for that it substitute is v. If you substitute in the above equations, we will get lambda is equals to h by mv. This is nothing but de Broglie's equations. mv we can also call as p. P is nothing but momentum. Means you see the electrons are moving. Correct? No, the electrons are moving. That time the movement means m is nothing but mass of the electrons are moving with a velocity. Speed nothing but velocity. Then called as p is nothing but momentum. H is equals lambda is equals to h by p. It is nothing but de Broglie's waves or matter waves. Okay, this is nothing but de Broglie's. Next we are going to talk about another one, nothing but significance. Significance of de Broglie's. De Broglie's, if you take a large mass and small mass, large mass and small mass. If you take a large mass in de Broglie's, we are substituting like a stone of the iron, mass having 100 grams, moving with the velocity. Similarly, we are taking that 1000 cm per second. You see, we are finding lambda. We get h is nothing but Planck's constant formula 6.62 into 10 to the power of minus 27, and if you substitute the numericals to the formula, will get lambda is equal to 6.62 into 10 to the power of 34 cm. For de Broglie's, we told that if large mass is there, then wavelength will be less. Similarly, if you see, it is 10 to the power of minus 32, 6.62 into 10 to the power of minus 32. If you take a small mass like electrons, we know that velocity of electrons and mass of the electrons, substitute in the formula, we will get lambda is equal to 3.3 into 10 to the power of minus 8. It is compared to more. If you take small mass, come to de Broglie's, if you take a small mass, it having wavelength more. Small mass having more wavelength. When come to large mass having small wavelength. Okay. Next we are coming to applications of de Broglie's equations to the Bohr's theory. You know that angular momentum mvr is equals to nh by 2 pi. The electrons are moving. No, the electrons moving. If you substitute 2 pi r is equals to nh by mv. We know that mv is nothing but p. The previous one I told in de Broglie's, while substituting the de Broglie's equations, if we can substitute p and h by p is nothing but lambda. We get, see, we got h by p is nothing but lambda. Correct? No. If we substitute this in the above equation, we will get 2 pi r is equals to n lambda. 2 pi r is nothing but radius of the means circumference of the electrons. You see, if in the phase the electrons are moving in the phase, it will be 2 pi r is greater or lesser than n by lambda. N lambda. If it is outer the phase, means you see it is outer the phase. You see the wave, electrons are moving in the wave out of the phase, out of the phase. Destructive interface or radiate energy. What is this radiating? Radiating is nothing but losing of energy. It's simply is wasting the energy while rotating the outside of the orbitals. See here what I'm telling you. See, I will show here. You can understand properly. The electrons are moving in the wave. If it moves in it will be it does not have irradiating energy. It does not lose any energies. Okay, it will be inside. If it moves in the outer side, so you see, it simply is wasting the energy. Okay. Next we are going to talk about Planck's quantum. Actually, before only I want to explain the Planck's quantum. I am explaining this because already you know that the Planck's quantum. You see, before going to Planck's, the Einstein given the wave formula, that is particles E is equals to h nu and E is equals to mc square. In 1905, when come to de Broglie told that it moves in de Broglie told that electrons are moving in the wave or particles will tell the matter. Okay, you see, when come to Planck's quantum theory in 1926, a black body radiates or absorbs the energy in whole numbers multiple of quantum. See, black body radiate means lose, correct? No, lose of energy or absorb energy in the whole numbers multiple of quantum. You see, if you taken a black body, if light is passed to black body, it will be heat. The black body will be heated. That time the emits the thermal radiation of the different wavelength or frequency. Means you take any black body, if you pass a light to that or keep to a sunlight falls on that, it become heat. That time that liberates the thermal radiations based on the wavelength and frequency. That wavelength and frequency burns off the energy. Means burns means it once some energies comes grouply, some energies come single. Means packetly. That called as the quantum is nothing but only one packet of energy. It is many packet of energy. The Planck's, we know that Einstein h is equals to h nu, correct? No, but Planck's given that h is equals to 6.6246 into 10 to the power of minus 27. You see, Einstein, this formula is given 1905, but Planck's given 1924. Up to this year, they not have the value of Planck's value. Now 1924 onwards, the value of Planck's they give given the 6.626 into 10 to the power of minus 27 error per second. If you change in another units, h is equal to 6.626 into 10 to the power of 34 joules per second. Okay. Next, we are going to study about Heisenberg uncentric principles. You see, now again I am telling this Heisenberg uncentric principles is given that Warner in 1927, Planck's given 1924, de Broglie's given de Broglie's, what they give, when he given de Broglie's 1923, Einstein 1905, and Planck's 1924, Heisenberg given that 1927. What he told that it is impossible to determine the means electrons are moving, correct? No, electrons are moving. It cannot be impossible to determine, means we cannot determine the position of the electron. We cannot tell electron is here only. We cannot tell. Compared to Heisenberg, we cannot tell. Okay, position and movement. Where it is moving? Here, the electron is here. How can we tell the position and momentum? We cannot tell. That only the Warner told, that is Heisenberg uncentric principle. It is impossible to determine the position and momentum simultaneously of an electron. Simultaneously we cannot find out. If we talk about first orbital, we tell that here means first, when come to second orbital, we cannot identify. Like that, we cannot identify the position and momentum of the electrons. The relation between pair of the conjugative properties. You see, we are talking about the conjugative properties compared to Heisenberg. We talk position and momentum. Position is delta x, momentum is delta p. We are denoted. Okay, delta position into momentum of the particle by the Planck's constant with the radius. Okay, this is, we got it. While the formula only delta, we know, you see, P we are taking, P already the previous what we told that P is nothing but when come to de Broglie's, P is nothing but mv. M is mass of the particle, velocity of the particles, correct? No, come to de Broglie's, but m is nothing but mass of the protons. Okay, delta P, change in momentum equals mass never changes, change in velocity, mass never changes, correct? No, electron with moving never changes the masses. If any outer extreme energies are formed, that time this mass will be changes, excess or decreases. Okay, or delta x into m delta v greater than equal to h by 2 pi. This is the Heisenberg uncentric principle. This is nothing but Heisenberg uncentric principle. Similarly, now we are going to talk about if we take a large mass and small mass. Large we take any stone with a mass of 500 we take here electron mass 9.1. If you see what happens, if large mass is taken when come to Heisenberg, it is negligible. If you substitute, if mass is 500, substitute to the equations, we get, see, you can see delta x into delta v, del is 6.626 into 10 power of minus 27 by 3.14 into 500, approximately 5 into 10 power of minus 34 error second per gram. See, it is negligible. See, if we take a large mass, that time the Heisenberg principle will tell it is negligible. When come to small mass, it is considered. Okay. If you see delta x increases, delta y decreases. Delta x means position increases, then momentum will be decreased. For example, position is decreases. For example, it is in first orbital, then its velocity will be, means vice versa. If position decreases, then what about the momentum? Momentum will be increasing. Small position, it moves fastly. In large position, moves slowly. Do you understand here? Delta x and delta v. This is nothing but Heisenberg concentric principles.